So there's an increasing discussion about talent shortage in the semiconductor industry, and it seems to be raising a lot of concerns. Now, what's your observation on this topic?
It's a very important topic. I agree with you that we are experiencing an acute talent shortage, especially for the semiconductor industry. And I have seen it grow over the decades. I was monitoring that, it is happening, and I was sort of speaking out. But apparently, the perception to young people about semiconductor industry was not strong enough. Therefore, most of the young people were looking at social media, Google, Facebook, and IT industry was growing, while the chip making sort of took a backstage as a visibility to young students. What they know is the end product. They look at the cell phone, they look at the computer screen, they go on Zoom, they go on video gaming and everything. What is missing is what's the technology behind that? What is inside your cell phone and how those chips are made? So the chips today are almost like a marvel of modern technology. We are going to nanometer scale, billions of transistors in a chip. Does it really excite young people? Do they know about it, how they're built? So that is what we have to promote in our education system, I believe. And I observed that. We had enrollment crisis started in early 2000 in our program on microelectronic engineering. So the big players who were hiring our students, like Texas Instruments, Intel, IBM, so they started showing up less in career fairs to attract more students. So I think that what we need is to reach out to starting from K through 12 to look for promoting semiconductor education early on to young students. We really need to sit down with industry and academia and society representatives, even K through 12 teachers. We have to flood the K through 12 curriculum with semiconductor engineering type of education. Do you think that an 8th grader or 10th grader in our schools knows about semiconductors? No. So I think we have to actually intensify our physical sciences curriculum in high schools. When I was in high school, my chemistry teacher taught me at that time that how nuclear energy can be used for peaceful purposes. For a 10th grader to teach that, I thought was great because that prompted me to come to physics. So if we do the same thing in our high schools, students will be taking a lot of interest in coming to this field. Show the cross-section of a chip to a 10th grader. How many multi-level metallization? How small is the transistor? Show them that, and then they'll be intrigued.
Do you agree that the shortage was caused by the gap between academic training and industrial needs?
That's a very good question, and I 100% agree with you. In our program, we have mandatory internship requirement. Our students go for internship in semiconductor industry. So after, say, first 2 years of BS program, and that's why we, as academic professors ourselves, we keep very good engagement with industry so that our curriculum is in parallel with what industry needs. But very few schools do that, and I think we have 40 years of history that we have worked very close to the industry and we teach what industry needs. And that's what we need to do more often, more internship opportunity for students. And also what we need is industry to collaborate with academia more. There should not be barricade or resistance between the two. We should invite the industrial people to give talks to our students, and we should ask our faculty to go and do sabbatical in the industry so that they can know what goes on in the industry. So I did sabbatical at IBM, and that helped me a lot in how industry works versus how academia works. And I think academia needs to put more fertilizer to undergraduate education and master's education, because 65% of semiconductor workforce are BS, MS students. The PhD takes a long time for your career to grow into. And after PhD, most of the people would like to have either a startup company job or academic jobs. But when you need production engineers running the tools in the fab, you need them to have at least the BS and MS education so that they can run the tools and they understand what goes on in the tools. It's not just mechanical work. They understand what's going on when you are in the fab. And that's what we teach here at RIT.